Hi. So we're going to solve another example. It's about general solution using variation of parameters. So here is our differential equation, y double prime minus y is equal to 1 over x. So in the first step, again, we are going to solve the associated homogeneous differential equation, that is y double prime minus y is equal to 0. So the auxiliary equation to this homogeneous differential equation is m squared minus 1 is equal to 0, right? Or from here, m sub 1 equals 1 and m sub 2 is equal to negative 1. So if we just write here the complementary solution, it will be c sub 1 times e to the power x plus c sub 2 times e to the power minus x, right? And the second step, we are going to find the particular solution to this differential equation. And we are looking for the particular solution in this form, that is c sub 1. But here, what is it? We assume that it is something like this: u sub 1 of x times y sub 1 of x plus u sub 2 of x times y sub 2 of x. So this y sub 1, we know this y sub 1, y sub 2, we know this, right? So here, if we can find this u sub 1 and u sub 2, then we can write the general solution to this differential equation. So we are going to use the method of variation of parameters to solve this, to find the values of these functions, u sub 1 and u sub 2. So to do this one, okay, we are going to use, in this method, first we need to find Wronskian determinant, right? And here we have y sub 1, y sub 1, y sub 2. All right. And here we have y sub 1 prime, y sub 2 prime, which is equal to y sub 1, it is e to the power x, and here we have e to the power negative x, and here we have the derivative of this function, e to the power x, the derivative of this function, minus e to the power minus x, right? And which is equal to, and this equals 1, right? Negative 1 minus 1, so that's equal to negative 2. Right. And now we need to find this w sub 1, which is in the first column. We need to write 0, and f is already in standard form, so our f is, so here our f function is 1 over x. So here we have 1 over x, right? And the second column, we have these functions, e to the power negative x, and here we have minus e to the power negative x, which is equal to 0 times this is equal to 0, minus 1 over x times e to the power minus x, that is e to the power minus x over x, right? So in similar way, we can evaluate w sub 2. So here we have y sub 1 prime, that is e to the power x, e to the power x. And here in the second column, here we have 0, f. What is f? 1 over x. 1 over x. So that's equal to, this is 0. So here we have e to the power x over x, right? So now we can find u sub 1 prime, which is w sub 1 over w. I don't know why we have these lines. Okay, w sub 1 is equal to this. So that is minus e to the power minus x over x times, here we have 1 over w. 1 over w is minus 1 over 2. That is equal to 1 over 2 times e to the power minus x over x, right? It is minus 1, so it is plus, and u sub 2 prime is w2 over w, that is equal to, w2 is this, e to the power x over x times minus 1 over 2. So that's equal to minus 1 over 2 times e to the power x over x. Right? Now, to find this u sub 1, we can actually integrate both sides. Here, u sub 1 is equal to integral 1 over 2 times e to the power minus x over x dx. But here we need to be just careful. We need to mention that when we are integrating this, we have to make sure that actually that's the integral interval, right? The interval that we are integrating over, it should not contain 0 because of this x. All right. Either we can just mention that x, actually any interval that we're integrating this function does not contain 0, or to mention that also I can put here integral limits. All right, actually here that means that we are integrating this function over this interval, x sub 0 and x, and here 0 is not here. This interval does not contain 0. So we can integrate this on any interval that does not contain 0. Or also without putting this integral limits, we should just mention that actually the interval that we're integrating over does not contain 0. Okay, let me just keep this in this way. And in a similar way, if we just write here, take this 1 over 2 out, e to the power minus x over x, that is non-elementary function. Okay, we cannot actually evaluate this integral. So we can just keep it like this. And u sub 2, the second thing, that's equal to integral from x sub 0 to x, negative 1 over 2 times e to the power x over x dx. Okay, so now I can write, you can just take this 1 over 2 out, negative 1 over 2 out, you can just keep this inside, doesn't matter. So now we can write the general solution of the given integral, that would be dot y of x, that is y complementary solution plus y particular. Complementary solution is this, that is c sub 1 e to the power x plus c sub 2 e to the power minus x plus now here we have y sub 1 times u sub 1. What is y sub 1? Y sub 1 is e to the power x, and here we have u sub 1, so that is 1 over 2 times e to the power x times integral from x sub 0 to x. What we have here, e to the power minus x. Actually here we have already x, so since we are using x, we need to change this because we should not confuse here. So this will be t and t dt, right? And also here we have t and t dt, right? So I better erase it and rewrite. So e to the power t over t dt. So here we have e to the power, here we have t, actually it's a function of x, right? Because of this x, e to the power t, oh, all right. Okay, the first one over t dt, right? And the second one is, it is minus 1 over 2 times y sub 2. What is y sub 2? E to the power minus x. E to the power minus x times integral from x sub 0 to x, any interval that does not contain 0. And the second one is e to the power t over t dt. Okay, actually we can just write it in a more compact form, but also this is fine. We can leave this in this form. All right, because if you just bring this inside, here we have e to the power x minus t, and here we have e to the power minus x minus t, and also we can just describe it, describe the solution using that harmonic functions, hyperbolic functions, that is sinh of x minus t. Okay. Anyway, so that is the general solution of the given differential equation.